A foldable phone can close until its two halves are parallel, but the screen between them does not fold into a paper-thin crease. If it did, the glass and electronic layers would be forced around an almost sharp corner, and they would fail very quickly. What actually happens is more interesting. The phone closes through 180 degrees, while the display curls around a rounded path inside the hinge. The device becomes flat on the outside, but the screen keeps a small bend radius on the inside. Start with the phone fully open. Under most of the display, rigid support plates give your finger a firm surface. Near the center, the support is different. It can move with the hinge, because this narrow folding zone must change shape. As the two halves begin closing, the support underneath stops holding that zone flat. The hinge controls where the phone rotates and gives the display enough room to bow inward instead of being pinched at one sharp line. Exact hinge designs vary, but their job is the same: control the path and the radius of the bend. Now watch three marks across the thickness of the screen. The mark on the outside of the curve has to travel farther than the mark near the middle. The mark on the inside travels less. That difference tries to stretch the outer material and compress the inner material. If the screen were one thick solid slab, that strain would build across the whole slab. Making each functional layer extremely thin reduces the distance between its two faces, so the difference in travel becomes smaller. This is the main reason ultra-thin glass can flex while a normal phone cover glass cannot. But the layers are not fused into one rigid block. Between several of them is a soft, transparent adhesive. It stays bonded, but it can shear, meaning it changes shape sideways by a tiny amount as the screen bends. That tiny deformation lets neighboring layers move slightly differently, instead of forcing every layer to stretch as one thick object. It also creates several low-strain regions through the stack. Engineers arrange thickness, stiffness, and adhesive behavior so fragile electronic films sit close to those safer regions. The top cover still has a difficult job. It must feel smooth, resist scratches, and survive tension on the outside of the bend. Foldable cover glass is made extremely thin and chemically strengthened, but it is still glass. A tighter bend or a damaged surface raises the chance of a crack. Below that cover is the working display. OLED helps because each pixel makes its own light. There is no separate rigid backlight behind it. The pixels and their tiny control transistors are built on a flexible foundation, and thin protective coatings keep oxygen and moisture away without adding a thick rigid shell. So during one close, four things happen together. The hinge sets a controlled curve. The support structure makes room for that curve. Thin layers keep their own bending strain lower. And the soft adhesive deforms between harder layers, so the stack can share the movement without separating. At the fully closed position, the two phone halves have rotated through 180 degrees. The display has not been crushed into a sharp crease. Its folding section is still wrapped around a small rounded path inside the hinge. That hidden space is part of the mechanism, not wasted room. When the phone opens again, the hinge reverses the motion, and the support structure returns beneath the display, helping it become flatter and firm enough to touch. But the same narrow zone has changed shape again and again. Its materials and supports do not all recover in exactly the same way, which is why reflected light can reveal a crease even when the pixels still work normally. This also explains why sharp pressure is dangerous. The phone is designed to spread a controlled bend across a known area. A fingernail, pen, or object trapped between the halves concentrates force at one tiny point, bypassing the protection created by the hinge and the layered stack. The simple answer is not that a foldable screen is made from one magical bendable material. The phone closes fully because the hinge preserves a safe curve, the support moves out of the way and returns, thin glass and OLED films reduce bending strain, and soft adhesive lets the layers deform together without behaving like one thick slab. The phone folds through 180 degrees. The screen survives because it never has to fold through a zero-radius crease.